This is a video lesson for Module 1, Lesson 2. The Lesson 2 learning target is I can recognize a digit represents 10 times the value of what it represents in the place to its right. So today we're going to be using the tool of a place value chart to help us do a little bit of multiplication and to see what happens when we multiply certain numbers by 10. Our goal by the end is to have an understanding that a digit represents 10 times the value of what it represents in the place to its right. So we're going to hopefully show that through multiplication and using a place value chart. So let's go ahead and take a look at the first problem here together. I have already set up a place value chart with all of my different place values in it from ones all the way up to millions. And I'm going to be showing what happens when we multiply two tens by 10. So to represent two tens on the place value chart, I can do it a few ways. One of the ways I could do this is to use discs or dots to represent each of the tens. So I'm just going to put two dots in the place value chart underneath the tens place here, and that's going to represent my two tens in the problem. Now, when I am multiplying two tens by 10, what I'm essentially doing is making 10 copies of those two tens. So I can do that with my discs. There's 4, there's 5 copies, 6 copies, 7, 8, 9, 10. But we've kind of run into a problem here because we have too many tens in the tens place. And so we can do some regrouping and regroup some of them into hundreds. So we can actually regroup 10 of them into 100 and the other 10 into another 100. So what we end up with as our answer is two discs in the hundreds place or 200. So where we started, we had two single discs in the tens place, and then we ended with two discs in the hundreds place. So when we multiplied two tens by 10, these two discs in the tens place became two discs in the hundreds place. Another way we can represent this multiplication is actually using the digit 2 and putting it in the tens place on the place value chart. And then we know from working with the dots just a little bit ago that this 2, when we multiply by 10, shifts over one place value to the left and then becomes two hundreds when we are multiplying by 10. So this is another way that we can use the place value chart to see that when we multiply a number by 10, the digit shifts one place value to the left and becomes 10 times larger. We get the same answer though of two tens being multiplied by 10 equaling 200. Now because the 200s is equal to the two tens times 10, we could say that this 2 in the hundreds place is 10 times larger than this 2 in the tens place. So the place value to the left is 10 times larger, the place value to its right. We can continue to see this relationship in place when we look at division as well. So I am going to be showing on the place value chart here the problem of 200s divided by 10, and we'll see what happens when we divide the 200s by 10. So I'm going to start using discs just like the previous problem. I'm going to put two discs in the hundreds place. And then when we're dividing by 10, we actually need to unpack each of these hundreds, and in each hundred is 10 tens. So this first disc right here, I'm going to unpack into these 10 tens. And the second disc, I'm going to unpack into these 10 tens. Now after I've unpacked, I can do my division now. I'm going to try to make 10 equal groups out of these discs. 7 groups, 8 groups, 9 groups, 10 groups. And we see that we are able to have two discs inside each group. So our answer from 200s divided by 10 is 2 tens, which equals 20. So just like in multiplication, we could see that when we're dividing by 10, these two discs simply become two discs in the place value to the right this time. So when we're dividing, we're shifting down a place value, but the number of discs stayed the same. And we can show this relationship just like before with digits. I can put the digit of 2 in the hundreds place to represent my 200s. And when I divide by 10, this 2 simply moves down one place value into the place value to the right, and thus becomes 2 tens or 20. So once again, we see the relationship holding true, in this case with hundreds and tens, that the place value, in this case the hundreds place, is 10 times larger than the place value to its right. And also it would be 10 times smaller than the place value to its left. So let's go ahead and see how we can use this understanding to help us with another multiplication problem. This time I'm just going to be multiplying 25 times 10. So 25, there would be a 2 in the tens place and a 5 in the ones place. And since I'm multiplying it by 10, I know that when I multiply it by 10, both digits are going to be shifting one place value to the left, and both digits are going to be becoming 10 times larger. So the 2 tens becomes 2 hundreds, the 5 ones becomes 5 tens, and then we're left with 0 here. So I get my answer of 250. So we see once again that relationship holding true, that when we are multiplying a number by 10, those digits simply shift over one place value to the left, proving that the place value, in this case like the hundreds or the tens, is larger or 10 times larger than the place value to its right. So the hundreds is 10 times larger than the tens, and the tens is 10 times larger than the ones place. So that does it for our lesson 2 video. So hopefully now you're ready to tackle all the problems in the problem set. But as always, if you need a refresher, you can come back and rewatch any parts of the video to help you learn and understand the concepts from lesson 2. Thanks for watching.